Hello, this is my second lab report for line charges. The purpose of this lab was to develop a more realistic and accurate model from Lab 1 and learning interactions of charges. The experiment was the same as the first lab, but I had to create a computational model for two charged tapes as an evenly distributed model. I created two U-tapes and determined that they were both positively charged since they were attracted to the negatively charged plastic pen. Then I measured the distance between two tapes when the upper tape started to float. The length of the tape was 0.2 meters, mass was 0.0002 kilograms, and after 3 trials of experiment, I got 0.0163 meters for the average distance between the tapes. Two big physics principles I used in this lab was the Coulomb's law, to calculate the electric force exerted on the floating tape by the bottom tape, and Newton's law to calculate the gravitational force acting on the floating tape. By setting the electric force and the gravitational force equal to each other, I could calculate the excess charge on the tape. To calculate the line charge on the tape, I first used the approximation or estimation method. I plugged in the net excess charge value I got from Lab 1, point charge, into the electric force equation and then increased or decreased the value and compared the electric force to the gravitational force until they became the same. The white arrow represents the electric force and the yellow arrow represents the gravitational force. Q in this approximation was 1.985 times 10 to the negative 8 coulombs. Then I increased the pieces of tape to 100 for better accuracy. I went through the same process and got a net charge of 1.972 times 10 to the negative 8 coulombs, which was slightly smaller than the previous method where I divided the tape into 10 pieces. The second method is calculating the net electric force by dividing the tape into infinitesimal pieces and then integrating them to get the most accurate and realistic value of the net charge. I call the top tape charge we are observing at as the observation location with vector x, y, 0, and the lower tape that generates the electric force as the source with vector x prime, 0, 0. The r vector would then be x minus x prime, y, 0. I will call the electric field and the charge of an infinitesimal piece of tape that are each dE and dQ. Then if I plug in the dQ equation to the dE equation and plug in the value of R, I get the first equation on the right. Then to get dF, I multiply it by dQ prime. Then the equation is integrated. Since dx and dx prime are the infinitesimal pieces of the two tapes, they are both integrated from 0 to L. After integration, I plugged in the y, k, and L values, and if I set the electric force value with an unknown Q equals to gravitational force, I could get the net charge Q as 1.963 times 10 to the 8 coulombs. The net charge I got from the approximation method and the calculation methods were slightly different. I believe this is because small errors can exist in my experimentational measurements and in calculations. It could also be due to insufficient number of divisions since the outcome of setting n equals to 100 was closer to the outcome of calculations when I set n equals to 10. In both of the methods, I had to make some assumptions for the calculations, which are ignoring air resistance and assuming that each U-tape had the same amount of charge evenly distributed. The net charge of the line charge was greater than the net charge I got when I considered the tape as a point charge. This is because in the line charge case, the charges on the end of the tapes are further away from the charges on the other tape, so the electric force exerted by them becomes smaller. Therefore, since the average distance between the charges become larger and the angle of the vector makes the y components even smaller, the net charge and the line charge should have a larger charge than the point charge to make the net electric force equal to the gravitational force, while the gravitational force stays the same for both the line charge and the point charge. This is the end of my lab report, and thank you for watching.